Okay, in this video I want to just talk you through the 4 questions that you had, the 2 algebra questions and then the 2 trig questions. The very first question we had here, question 1a, we were told that p is a root of this cubic. We're told that p is an element of z, and that was really important for the answer. Remember that if p is an element of z, that means it's an integer, it has to be a whole number. But more importantly, if p is a root, then that means you can just sub it in. The form in which we usually use write roots is we write it as x equals 3 or x equals minus 4 or whatever. So we're being told here that x equals p is a root. That means that everywhere there's an x you can sub in a p and let the whole thing equal to 0. So if we just sub in now, we'll see what happens. So when I sub in here, everywhere there's an x, I just sub in a p. So this x cubed becomes p cubed, this is a p squared, and this is a p. Now, obviously the first term is straightforward enough, it's just 3p cubed. Then I'm going to multiply p squared by p and get p cubed, p squared by 3 and get 3p squared. For most of you, it seemed to be this part that caught a lot of you out. All you're doing is multiplying p by the bracket. P by 7 is 7p, p by minus p is minus p squared, and p by minus 4p squared is minus 4p cubed. And then you just have a minus 4 tagging along at the end. What I did on the next line was I grouped all my like terms. 3p cubed plus 1p cubed is 4p cubed, minus 4p cubed means they actually just end up cancelling each other out. I have 3p squared minus 1p squared, which is 2p squared, and then I have a 7p and a minus 4. At this stage, you just have a quadratic equation, so you could factorize it. The factors are 2p minus 1 and p plus 4. You add each factor equal to 0, and the 2 answers here were p equals a half or p equals minus 4. However, the question tells you at its top that p is an element of z. In other words, p is an integer, which is a whole number. So p equals a half is not fair game. The answer for the first part of the question was p equals minus 4. In part B, we're asked to hence solve the cubic equation. So in order to solve a cubic equation, usually what we would do is we'd use trial and error to find the first root, and then turn your root into a factor and use a long division to find the other factors. However, it's going to be slightly different this time. First of all, we've worked out from part A that p is equal to minus 4. So the first thing you should have done is taken the line on the top, and everywhere there's a p, you sub in a minus 4. So that's what I've done. This is what was given in the question, and everywhere there's a p now, I've just subbed in a minus 4. So you have 3x cubed, and in here you have minus 4 plus 3, so it becomes minus 1x squared. Now in front of the x was probably the trickier one. You have 7 minus p, which becomes 7 minus minus 4, and then you have minus 4 times p squared, which is minus 4 times minus 4 squared. Now you can plug all of that into your calculator, and when you do, you get minus 53. So I obviously have minus 53x minus 4 equals 0. So now at least we have a cubic, and all we have is numbers. At least there's no more unknowns. I've just got a normal cubic. Now at the start of the question, we were told that p was a root. But now I know that p is equal to minus 4. So I know that minus 4 is a root of this cubic. If you know one of the roots, in order to find the other roots, I need to convert the root into a factor. If x equals minus 4 is a root, you add 4 to both sides, and you end up with x plus 4 equals 0 is your factor. If you know one of the factors of a cubic, you can use a long division to find the other factors. So we just divide x plus 4 into this cubic, and that will tell us what the other factors are. So in order to carry out the long division, you should set it up like this. The first thing I need to do is divide x into 3x cubed. X into 3x cubed goes 3x squared times. Then I need to multiply 3x squared by x, and it gives me 3x cubed. 3x squared by 4 gives me 12x squared. The next thing I want to do is subtract, so I need to change my signs. So you draw a line underneath this becomes a minus, and this becomes a minus. 3x cubed minus 3x cubed is 0. Minus x squared minus 12x squared is minus 13x squared. And then you take down the next term, which in this case is minus 53x. And then we just start our process all over again. X into minus 13x squared is minus 13x. Minus 13 by x gives you minus 13x squared. Minus 13 by 4 gives you minus 52x. Change your signs, so this becomes a plus and this becomes a plus. Your x squareds will cancel. Minus 53 plus 52 gives you minus 1x, and you take down your next term, which is a minus 4. Then you divide x into minus x, and that gives you minus 1. Now you multiply minus 1 by these. Minus 1 by x is minus x, and minus 1 by 4 is minus 4. You change your signs, this becomes a plus, this becomes a plus, and everything cancels and you're left with 0. Now usually when you get to this stage, all you have to do is factorize this. Usually now, to find the roots of your cubic, you would just factorize 3x squared minus 13x minus 1. However, look at the way it was worded in the question. It asked you to leave any irrational roots in the form a plus or minus root b over c. So obviously the only way I'm going to find the roots of this quadratic is I'm going to use the minus b formula. Once we use our minus b formula, we'll have the roots of our cubic and we'll be on full marks for part b. So it's straightforward from there. We just need to use the minus b formula to factorize 3x squared minus 13x minus 1. Clearly a in this case is 3, b is minus 13 and c is minus 1. When you sub into your minus b formula, you should end up with x is equal to 13 plus or minus the square root of 181 over 6. So there are two of your roots. One of them is the plus, one of them is the minus. Whenever you're asked to solve a cubic, I advise you to always write the three roots beside each other. So I've also tagged along the other root I know for this cubic is x equals minus 4. So they're the three roots and you've managed to solve your cubic. So it's full marks for part B if you got to this stage. Okay, the last part of this question, you were given a cubic and you could clearly tell by looking at the cubic what the roots of the cubic were. Remember that the roots of a cubic are the points where it crosses the x-axis. You were told that this cubic can be rewritten in the form ax cubed plus bx squared plus cx plus d. And you're asked to find the coefficients, find your a, b, c and d. The first thing you should have honed in on was the points where this curve crosses the x-axis. It crosses the x-axis here at 3, which tells me that one of the roots of this cubic is 3. It crosses the x-axis, or it turns on the x-axis at minus 2. At a turning point, if it turns on the x-axis, that means that there's two roots at that point. So the three roots of this cubic are x equals 3, x equals minus 2, and x equals minus 2. If x equals 3 as a root, you need to turn it into its corresponding factor. In order to turn x equals 3 into a factor, you subtract 3 from both sides. And you end up with x minus 3 is equal to 0. If x equals minus 2 as a root, you add 2 to both sides to turn it into a factor. So I get x plus 2 equals 0. You do the same thing, obviously this is the same, you end up with x plus 2 equals 0. And now if I multiply the three factors by each other, that will give me the equation for a cubic that has these roots in it. So it's very straightforward to work through this. We just multiply x minus 3 by x plus 2 by x plus 2. And when you do that, you should end up with x cubed plus x squared minus 8x minus 12. However, there's a catch to this one. The answer you get here is a plus x cubed. A plus x cubed is that shape. Our graph is the opposite shape, so clearly we don't have a plus x cubed, we have a minus x cubed. And you need to know that the number at the end, the constant at the end, is the y-intercept. So the cubic you're after coming up with looks the other way. The cubic you're after coming up with, it has the same roots. It crosses, it turns at x equals minus 2, and it looks like that. It has the same roots. It crosses at 3, and it turns at minus 2. So you're actually after finding the equation of this cubic that crosses the y-axis at minus 12, it turns at x equals minus 2, and it crosses through the x-axis at x equals 3. The problem is there are an infinite amount of curves that have the roots 3, minus 2, and minus 2. I could draw another one that's much steeper, and I could draw another one here that's much steeper. There's loads of different ones I could draw. So the key for you to work out how to get your final answer, you should always hone in on this number here. Clearly, you can see from your graph that the y-intercept of your graph is 24. Okay, the y-intercept of your graph is 24. At the moment, you've got a minus 12. You need to ask yourself, what do you need to multiply minus 12 by in order to get to plus 24? obviously what you need to do here is multiply this entire curve by minus 2. You multiply it by a minus, it changes its shape, so that you'll have a minus x cubed, which is the shape that we're looking for, and you multiply it by 2 so that it's twice as steep, so that it, rather than intersecting at 12, it intersects at 24. So you multiply these three factors by each other and you got this one, which I think most of you did, no bother. But now you have to multiply everything by minus 2. This will become minus 2x cubed minus 2x squared plus 16x plus 24. Now this makes sense. You have a minus x cubed, and a minus x cubed is a u and then an n, which I'm happy out with. And the y-intercept is 24, which makes sense based on the diagram you've been given. So your final answer for this part of the question was that a was equal to minus 2, b is minus 2, c is 16, and d is 24. So let's move on now and look at question 2. Okay, question 2 is probably the easiest question on the paper. You're given two equations with two unknowns and you had to do a simultaneous equation. You're given x squared minus 3y squared equals 13 and x minus y equals 3. Since there's squareds involved here, you should have recognized that this is substitution. You take your simple equation and you isolate either your x or your y. I've decided here to add y to both sides so that I can say x is 3 plus y. I then went back to the main question, and everywhere there's an x, I know that I can sub in 3 plus y. So now all I have is one equation and one unknown, which means I can solve to find the value of y. You multiply 3 plus y by 3 plus y, and when you do that you get 9 plus 6y plus y squared. And at this stage I had a y squared, a y, and a number, so I realised that this must be a quadratic equation. So you bring everything to the right hand side, and I ended up with 0 is equal to 2y squared minus 6y plus 4. Before I factorised this, I decided to simplify it by dividing everything by 2. If you divide everything by 2, you get y squared minus 3y plus 2 equals 0. The factors of that quadratic are y minus 2 times y minus 1. You let each factor equal to 0, and I realised that y equals 2 and y equals 1 are my two answers for y. Once you've got two answers for y, you should sub back into this in order to find the corresponding values for x. If y equals 2, I can use the fact that x equals 3 plus y in order to work out x. In the scenario where y is 2, x is 3 plus 2, or in other words 5. In the scenario where y is 1, x is 3 plus 1, or in other words 4. Now there was nothing in the question to indicate that you should leave your answers as coordinates, but just to be safe, when you're dealing with x's and y's, I usually tell students, like, there's no harm, you definitely won't lose marks for writing it as a coordinate. So I wrote my answers as 5, 2 and 4, 1. Okay, there was 15 marks going for part B, and it's relatively straightforward, but students tend to mess up the last few lines, so I really want to focus on the end of this question. You had 3 over 2 minus x is less than or equal to 1. If you have an algebraic inequality, or in other words algebra on the bottom and an inequality, this is what's known as the special case, and you multiply both sides by the denominator squared. The denominator in this case is 2 minus x. So I'm multiplying both the left hand side and the right hand side by 2 minus x. On the left hand side, the 2 minus x on the bottom will divide into one of the 2 minus x's on top. And I'm actually just left with 3 times 2 minus x, which is 6 minus 3x. On the right hand side, you just multiply 2 minus x by 2 minus x, and you get 4 minus 4x plus x squared. And at this stage, you should recognise that you've got a quadratic, so you bring everything to one side, and you end up with 0 is less than or equal to x squared minus x minus 2. Now, it's from here that I want to really focus. What we want to do now is we're going to let the quadratic equal to 0. The reason you're letting it equal to 0 is so that you can sketch yourself a curve. So I had my inequality here and I just changed it to an equals. And now I want to find the roots. If this quadratic was equal to 0, what are its roots? So I factorised this and I solved, and my roots were x equals 2 and x equals minus 1. So they are not your answers. It's not the answers at all. That's if it was equal to 0, these would be your answers. That allows me to sketch the quadratic. So x squared minus x minus 2 looks like this. And when I've sketched my quadratic, I can use this graph to answer this question. The question is, when is the quadratic greater than or equal to 0? It's greater than 0 when the curve is above the x-axis. So it's these two regions. You need to recognize that these are two separate regions. So to get the marks here, you have to give me two separate answers. When my x value is to the left of -1, the curve is above the x-axis. So obviously to describe that region, to the left of -1 refers to values that are less than or equal to -1. When x is less than or equal to -1, this quadratic is greater than 0. Greater than or equal to 0. The other region I'm looking for is to the right of 2. When x values are bigger than 2, the curve is above the x-axis. So my second answer is when x is greater than or equal to 2. Now I've put in the equal to there because a lot of you did, but that's a mistake. I shouldn't have the greater than or equal to there. Look at the original line. In the original question, on the bottom of the fraction, you had 2 minus x. If x is equal to 2, I'd be subbing in 2 minus 2. The bottom of this fraction would be a 0. You are not allowed to have a 0 on the bottom of a fraction. It's undefined or it's infinity. So x cannot be equal to 2. So you have to eliminate the equal to there. Your two answers are x is less than or equal to 1 or x is greater than 2. Those two regions describe when this quadratic is greater than or equal to 0. Okay, in question 3 here, we were given a trig graph. And we're told that h represents the height of the water in a port. And that t is time in hours. Now you should just recognize this straight away. In a question like this, my advice to you is sketch a rough graph immediately. The way that we did it in class, I got you to sketch like 40, 50 graphs in one class. That's what I advise you to do in these questions always. This is a positive cos graph. There's a plus in front of the cos, which means it starts at the top. Positive cos graph starts at the max and it looks like that. The number on its own refers to the midline. So I know the midline of this graph is 1.6. The coefficient of cos, or the number in front of cos, refers to the amplitude. In other words, how much I deviate away from the midline. So if my midline is 1.6 and I go up 1.5, my max must be 3.1. If the midline is 1.6 and I go down 1.5, the minimum must be 0.1. And remember that we have a formula to work out the period. The period of one of these graphs is always 2 pi divided by c, where c is the coefficient of the variable in the angle. In other words, pi over 6. So to work out the period of this graph, it would be 2 pi divided by pi over 6. If you plug that into your calculator, it's 12. And obviously then we should figure out what the units are. The units here are hours. So the period is in fact 12 hours. So that means I started at the top, went down to the bottom and back up to the top after 12 hours. Now, my advice to you is I would do that before you even read the questions. You just do that at the start of a question and it'll just make your life a lot easier. Now I would point my attention to the actual questions. Part A asks you to work out the period and the range. So the period of this graph, if you follow the generic template that we used in class, we've already worked out that the period of this graph is 12 hours. And it's important that you put in your units there. A lot of people forgot their units. And the range, well, I've already worked out the range here. The maximum is going to be 3.1 meters. The minimum is going to be 0.1 meters. Once again, there was a lot of dodgy answers with no units in that. The maximum is 3.1 meters, while the minimum is 0.1 meters. So that's your answer to part A. Now part B, it's kind of overlapping part A, but part B it asked you what's the maximum height. Obviously, you've actually answered it from part A anyway. The maximum height reached is 3.1 meters. So there are your full marks for A and B. There's no actual marks going for that, but my advice to you is just sketch it because it makes your life so much easier. Now we jump straight then to part D. You'll notice we skipped to part C, but this is from a Leave Insert question and there was a different topic. Part C was a completely different topic, so we skipped it. In part D, you have to type in the function, typing in 0, 3, 6, 9, 12, 15, 18, 21 and 24. I think most of you eventually got there. There was a bit of people struggling from not having their calculator in radians. Make sure you're comfortable converting from radians to degrees. You'll notice at the start of this question, it told you that pi over 6t was in radians. So that tells you have to have your calculator in radians. When you plugged in all your values, you got 3.1, which is the max, down to 1.6, down to 0.1, and it just went up and down. It just ended up looking like a cost graph. It started at the top and it repeated itself every 12 hours. We'd already worked out the period was 12. Now, you'll notice that when we were learning this, we always had everything oscillating around the midline, and we had a big, strong horizontal line for our midline. In the exam questions, you'll have an x and a y axis, so you don't even need to draw in the midline. You don't lose marks if you do, but my advice to you is use a broken line just to help you draw your graph. You do a broken line to where the midline would be, and it just helps you visualize what's actually going on. I'm just oscillating around 1.6, it's getting deeper and shallower and deeper and shallower, and it repeats itself every 12 hours. So your marks were going there just for plotting your points. I think in most cases, most of you got full marks in that, so it was relatively good. Okay, question 4, the first few parts were relatively straightforward. Question 4, you had a right angle triangle CBE. Well, clearly we knew that this was a 90-degree angle, and you were asked to find the distance BE. If you're dealing with a right angle triangle, you just need to think about junior cert trigonometry. It's either Pythagoras theorem or you're dealing with sine, cos and tan. Now clearly here, since there's an angle involved, we're talking about either sine, cos or tan. You should have identified that if this is the angle you know, you're looking for the opposite, and you have the hypotenuse. If you're dealing with the opposite and the hypotenuse, then you're dealing with sine, because I know that the sine of an angle is the opposite over the hypotenuse. If I use that, I end up with the sine of 48 is equal to the opposite, which is the distance BE, over the hypotenuse, which is the distance 2.9. And at this stage, you had to realise that you needed to eliminate your fraction. In order to eliminate your fraction there, you multiply both sides by the denominator. Multiply both sides by 2.9, and you get the distance BE is 2.9 sine 48. If you plug that into your calculator, remember you have to switch back into degrees here because this is 48 degrees. It's not in radians anymore. The question asked you to leave it to 2 decimal places, so your answer should have been 2.16 meters. In the second part of this question, you were asked to find the angle ADF. In other words, the angle here at D. And you know all three sides in this non-right angle triangle. Remember, if you're dealing with a non-right angle triangle, you're looking at the formula on the top of page 16 in your maths tables. It's either the sine rule, the cosine rule, or the area of a triangle formula. Now clearly it's not the area of a triangle, it's either the sine rule or the cosine rule. You need to remember that if you know 3 sides in a non-right angle triangle, in order to work out one of the angles, you use the cosine rule. Because in the cosine rule, there's an angle and then there's A, B, and C, all 3 sides. So in this case, I know A, B, and C, the 3 sides. The only thing I don't know is the angle A. Remember that there's a relationship between each angle and its opposite side. So if this is the angle I'm looking for and I call it A, I have to call this small a. A has to be 3.7. And then B and C are just whatever you want. So I'm going to label my 2.4 as my B and my 1.8 as my C. You could have done it the other way around and it makes no difference. Now, when we were learning the cosine rule, we addressed this situation where you have 3 sides and you're looking for an angle. It's easier if you manipulate the formula first. So on page 16, it tells you that a squared equals b squared plus c squared minus 2bc cos a. But if you're looking for the angle, you should manipulate the formula so that you can isolate the cos a. So you've only got cos a on its own. So what I did first was I subtracted b squared and c squared from both sides, in which case the left hand side is a squared minus b squared minus c squared, while the right hand side I'm just left with the term that has the cos a in it. In order to get cos a on its own, I decided to divide both sides by minus 2bc. Now if you're looking for an angle, it's easier if you manipulate the cosine rule first. Now all I have to do is sub in a, b and c and I'll be able to work out my angle. So all I have to do here, I subbed in my A, B and C, plug it all into your calculator in one go, and you get cos A is minus 469 over 864. So in order to get the angle A on its own, you get cos inverse of the left hand side. cos inverse of the fraction works out as 123 degrees. And that looks fair enough. Based in your diagram, the angle that you have there, it's obtuse, it's clearly bigger than 90 degrees, and it looks like about 123 degrees, so that makes sense. So that was your answer to the nearest degree for part 2. Okay, in the third part of this question, you were asked to find the distance EF, this distance at the top. Now, all I've done here is labelled in the quantities that are relevant to this question. In order to get EF, what we're going to do is we want to find the total distance from B to F, the entire distance, and then subtract our first answer. In our first answer, we worked out the distance from B to E. The distance from B to E is 2.16. So if I can get the entire distance from B to F and subtract 2.16, I'll be left with the distance EF. But to be honest, my advice to you there is I wouldn't focus on that first of all. What I would have focused on was the word hence. It says hence find the distance EF. So obviously the fact that you're after working out that this angle is 123, that must be useful for finding EF. The thing that I can do, if that's 123, you should realise that clearly we have a straight angle here. If that's 123, 180 minus 123 gives me 57 degrees. I know that that angle is 57 degrees. And this is a right angle triangle. The triangle ABD is a right angle triangle. I know the hypotenuse of this triangle is 2.4 meters. And if I know that that angle is 57, so I know an angle and I know the hypotenuse, that's enough information to find anything else that I want. The thing that I want to find here is the distance BD. If I can find the distance from B to D, I'll be able to work out what the total height from B to F is. So let's just look at the right angle triangle ABD. Okay, I have the angle 57, so if I was talking about the side BD, that's the adjacent. And if I'm talking about this side AD, that's the hypotenuse. If you're dealing with the adjacent and the hypotenuse, you're dealing with cosine. I can say that the cosine of 57 is equal to the adjacent, which is dB, over the hypotenuse, which is 2.4. So in order to get the distance dB on its own, I just multiply both sides by 2.4. And I could say that 2.4 cos 57 is equal to the distance dB. If I plug all this into my calculator, I'll work out my distance dB. When you plug it into your calculator, you end up with the distance dB is 1.31 meters. Now I have enough information to work out the distance EF. So all I've done here is I've drawn the line that's in the middle. I have 4 points on the line B, D, E and F. It was given in the question that the distance from F to D is 1.8. We're just after working out in the right angle triangle on the bottom that the distance from D to B was 1.31. And in the first part of the question, we worked out the distance from B up to E is 2.16. So clearly, in order to find, the question is to find the distance from E to F. In order to find that distance, it's just going to be 1.8 plus 1.31. That adds up to 3.11. The whole thing is 3.11 meters. And all I need to do is subtract the distance BE. 3.11 minus 2.16 gives me 0.95 meters. This distance here must be 0.95 meters. It asked you to leave your answer to 2 decimal places, so that was your final answer for part 3. Okay, in the last part of this question, I know a lot of you had to rush it, but for the most part, people seem to be comfortable enough. We've cos 2x equals minus root 3 over 2. The vast majority of leaving cert questions where this comes up has a coefficient in front of the x. If there's a coefficient in front of the x, the very first thing you should do is change your domain. If you're looking for x between 0 and 360, that means you're looking for 2x between 0 and 720. You double your domain, and that's the very first thing you do. The next thing I would look at is getting my reference angle. If you go to page 13 in your maths tables, if you look at your table, go down to cos and work across to root 3 over 2, if you look up, the reference angle there is 30 degrees. Alternatively, you could have just got cos inverse of root 3 over 2 in your calculator. Now I need to figure out what quadrants are relevant to this question. Remember your A, S, T, C. The quadrants in which cos is negative is the second quadrant S and the third quadrant T. So I need to get a value in the second quadrant and a value in the third quadrant. Remember that we always start at 0 and then work in an anti-clockwise direction. If you're starting at 0, by the time you've done half of a revolution, you're at 180 degrees. And I want to go back into S, or into the second quadrant. So mathematically, that's 180 minus your reference angle. So your first answer here is 150 degrees. To get a value in the third quadrant, you do half a revolution and you continue on into the third quadrant. If I'm continuing on, I'm adding my reference angle. So it's 180 plus 30, which is 210. So that's your answers if you did one revolution. But I need to do 2 full revolutions because I'm going as far as 720. So that means I'm no longer thinking about 180 degrees. I started at 0 and I did a full revolution and got to 360. And if you continued on, after 1.5 revolutions, you're at 540 degrees. This time, to get a value in the second quadrant, it's 540 minus your reference angle, which is 30 degrees, which gives you 510. To get a value in the third quadrant, it's 540 plus your reference angle, which gives you 570. Now, what we've worked out are our values for 2x. The values for 2x are 150, 210, 510 and 570. But obviously I don't want values for 2x, I want to find the values of x. So you need to divide everything by 2. And your 4 answers in this case will be 75, 105, 255 and 285 degrees. Notice how your 4 answers are within the original domain. The original domain was asking you for values of x between 0 and 360, which is what I've given my examiner in this case. So that was the last piece of that exam. For the most part, I think a lot of you struggled with time. To be honest, at this stage, I wouldn't worry too much about the time, but it's really important that you understand this now that I've gone through it with you. If you didn't get it in the exam, it's not the end of the world, but make sure that you go through this test in detail and you understand it fully.